2 millennia ago, hidden within the Amazon, an entire civilization sustained millions using dirt that by all logic should have been barren. They achieved this with a singular material, a pitch-black powder that runs under $2 a pound today. Apply it just once, never again, and the ground remains lush right now, 20 centuries later. This is no myth. It is a lab-verified reality, and it begs a vital question. If something this effective already exists, why has nobody at your local nursery brought it up? The worldwide fertilizer market rakes in upward of $230 billion annually. Add weed killers, acidity adjusters, nitrogen boosts, and microbes, and that figure skyrockets. Every flashy bag on the shelf relies on one core belief, that our dirt is permanently broken, and the only cure is buying more stuff, spring after spring, year after year. Yet, a quieter alternative exists. A route where a single affordable addition creates a self-renewing environment so balanced it never needs rebuilding. Massive heirloom tomatoes, blooming roses, foliage so vibrant your neighbors want your secret, all coming from biology, not chemicals, activated once and left to thrive. This is the tale of biochar, the underground secret perfected by Amazonian tribes, which modern industry has little monetary reason to discuss. The science checks out. The impacts are undeniable. And by the end of this, your garden will never look quite the same. Part 1. The puzzle of the dark dirt. Here is a fact most gardening guides skip over. The Amazon jungle, despite its lush green canopy, rests on some of the poorest agricultural dirt on Earth. That seems incorrect. It is worth explaining why it makes perfect sense. In a tropical rainforest, nutrient cycling happens almost entirely above the surface. Trees hoard the riches. When a leaf drops, shallow roots devour it immediately. The earth below is incredibly thin, highly acidic, and completely stripped of the decaying matter vegetables require to grow. Wipe out the timber, and what remains is red clay dirt that bakes into brick under the sun and washes away with the first heavy downpour. Traditional slash-and-burn farming exhausts a plot in just 2 or 3 years. The grower moves on, chars a new patch, and the loop starts over. So, when Spanish explorer Francisco de Orellana navigated his crew into the Amazon basin in 1542, he anticipated an impassable wild, maybe a few scattered tribes at most. What he actually encountered stopped him cold. Huge communities spanned the river shores for miles. His writers guessed populations in the millions, and bordering those metropolises were vast agricultural fields yielding abundant food from the exact same plots, seemingly for centuries. How? The solution was literally under their boots. Stretching several feet deep beneath these villages was a rich, almost black dirt, strikingly different from the weak red clay found everywhere else. The locals called it Terra, Preta de Indio, the dark earth of the Indians. Scoop untouched jungle dirt nearby, and the contrast was stark. Weak, shallow, and dead on one side, deep, dark, and buzzing with life on the other. Same rainfall, same weather, same geography, completely distinct dirt. For centuries, Western academics brushed it off. True investigation did not kick off until 1966, when a Dutch soil expert named Wim Sombroek released a groundbreaking text called Amazon Soils. When today's scientists finally tested samples of Terra Preta, the biological activity shattered their normal measuring limits. But here is the detail that truly shook the scientific world. Left completely alone, Terra Preta expands. It transforms the exhausted dirt, touching it into its own dark, fertile reflection. Gradually and persistently, with zero human help. Experts initially guessed the richness sprang from typical organic matter, rotted scraps, fish carcasses, animal droppings. Logical enough. But radiocarbon dating revealed a different narrative. The carbon inside Terra Preta was millennia old, and it was not rotting. Normal organic carbon degrades. This was not normal. It was char, what the scientific community now calls biochar. Those early Amazonian societies did not just compost their waste. They purposely manufactured charcoal under precise conditions and folded it into their fields. They constructed an underground architecture so resilient that over 2 millennia after their societies fell, the Black Earth remained, just as productive as the moment it was formed. Which brings us to a massive question. If biochar is capable of all this, what exactly is going on at the microscopic level, and why does it endure for so long? Part 2. The science of the black powder. Most of us have watched a campfire burn down. Complete burning changes the wood into water vapor and carbon dioxide. The carbon vanishes as smoke, leaving behind a pile of soft, powdery ash, which offers almost zero value for a garden. But if you alter just one detail, the outcome changes entirely. Bake organic matter like branches, crop stems, or even nutshells at high heat, but cut off the oxygen so it cannot entirely catch fire. This method is known as pyrolysis. The active gases boil off, the inner cell walls collapse, yet the underlying carbon skeleton, the tough, microscopic blueprint of the original plant, holds its shape. What you get is not ash. It is a honeycomb of solid carbon with a design so complex that just 1 gram of good biochar holds between 200 and 400 square meters of inner surface area. To picture that, imagine the space of about 4 tennis courts packed into a single speck you could hold between your thumb and pointer finger. That massive size matters. Let me explain why. A healthy garden is not really about the dirt itself. It is about the tiny life forms swimming in it, the fungi, bacteria, and invisible helpers that unlock nutrients for your roots to drink. These little workers are microscopic. The tiny gaps between sand and clay are their whole universe, and they hate being out in the open. A hard rain washes them out. Bright sun bakes them alive. They do their best work when they have safe places to hide and build steady colonies. Biochar provides exactly that safe haven. Every single flake is packed with millions of tiny caves, tubes, and rooms. Fungal threads weave right through them. Helpful bacteria line the inner floors. Creatures that would usually flush right out of sandy dirt now have a forever home. The sheer number of microbes living inside one chunk of biochar can be massively higher than in the plain dirt sitting just a hair away. That is not a minor bump in numbers. It is a completely different living world. And here is the key point that flips everything you know about gardening upside down. Biochar does not act as food for the dirt. It acts as a house for the creatures that feed the dirt. That single idea is worth repeating because it shatters the main belief behind every bag of plant food you have ever bought. Feeding is just a quick fix. Every jug of chemical fertilizer acts like a sugar rush, giving plants fast food that always leads to a hard crash. The earth itself remains starving. The tiny microbes multiply for a moment, then die off as soon as the chemicals wash away. It is a roller coaster cycle of boom and bust. A quick win today, but an empty bank account tomorrow. Housing, on the other hand, lasts. Once the living community moves into the biochar network and sets up shop, something amazing happens. Special fungi, which act like massive extensions for plant roots, dig through these tiny tunnels to grab minerals the roots could never reach on their own. They rip hidden phosphorus out of tight dirt particles and hand it straight to the plant, trading it for sugar. At the same time, helpful bacteria move into the rooms next door and start grabbing nitrogen right out of the air. They turn it into a form the plant roots can drink up, completely free, with no plastic bag needed. This is exactly how Terra Preta seems to grow all by itself. The buzzing community inside it slowly mends and upgrades the tired dirt all around it, season after season, without any extra help from you. So, the science makes sense. But if this is totally real, and it absolutely is, an awkward question pops up. Why does everyone not know this? Why is there no biochar section at the local garden center? Part 3. Why it stays a secret. The chemical plant food business is massive. The biggest players pull in tens of billions of dollars every single year. Toss in bug sprays and weed killers, and that number jumps even higher. Their whole way of making money rests on one simple idea. Dirt is just a dead bucket. Dump in artificial nitrogen and phosphorus, then pull out your tomatoes. The bucket empties out, you buy more product next spring, and you repeat this forever. If your ground gets hard or too acidic from years of using these chemicals, they have another bottle to sell you for that, and another spray for the new problem that bottle creates. The loop feeds itself and makes a ton of cash. Biochar breaks that cycle right at the base. Not because it swaps one fertilizer for a different brand, but because it slowly removes the need to add anything from the outside at all. A massive study from 2009 watched dirt treated with biochar over a 12-year span. By the end of that window, those gardens needed almost half as much outside fertilizer. By year 15, the need for chemical sprays had basically vanished. Looking at it as a business owner, that is absolutely not something a chemical company wants to advertise. A single purchase that makes the buyer stop needing you is the exact opposite of a good business model. This is not some wild secret plot. No one held shadowy meetings to hide biochar. It is much simpler than that. Science money naturally flows toward products that keep selling every year, not toward tricks that make the buyer totally independent. Gardening magazines survive on ad money from these chemical giants. The way the money is set up just does not reward anyone for talking about biochar. Still, the data is out there, and it is incredibly impressive. A massive review analyzing hundreds of global studies showed that regular biochar use bumps up crop harvests by nearly 11% on average. It increases the organic carbon inside the dirt by over 50%. And if you pair it with standard fertilizers, biochar can drive yields up by as much as 48% compared to untreated ground. Plumper tomatoes, more vivid blooms, and more robust roots, all while spending less cash and breaking less sweat, dragging heavy sacks from the store every spring. But bigger harvests and fatter wallets are just the beginning. What biochar does for human health and the climate makes this story even harder to ignore. Part 4. Armor for your health and the environment. Farming creates massive amounts of leftover plant trash every single year. When farmers burn it in the open or let it rot, it spits out methane and nitrous oxide greenhouse gases that are intensely more powerful than carbon dioxide. Nitrous oxide alone holds in about 300 times more heat per molecule. Changing that exact same yard waste into biochar through pyrolysis completely flips the math. Research proves biochar drops soil methane output by over 13% and slashes nitrous oxide emissions by more than 21%. Rather than letting carbon cycle back into the air, biochar traps it underground, stable, harmless, and locked away for hundreds of years. You are building a permanent carbon vault, one planter box at a time. Yet, here is the perk that truly counts if you grow food for your loved ones. Decades of modern industry have sprinkled heavy metals like lead, zinc, and cadmium across dirt nationwide. These toxins can quietly seep into the roots of your vegetables. The harvest looks flawless. It tastes delicious, but the poison is hiding inside. Biochar's massive inner surface works as a heavy-duty filter. Its sponge-like design and unique chemistry grab heavy metals and trap them, locking those toxins away so they cannot ever touch your plant roots. Mixing biochar into your soil is, literally, cleaning the earth before you even drop a seed. If you have spent years gardening near a busy highway, an aging house, or on old commercial land, this is a massive deal. It takes you from crossing your fingers that your dirt is safe to actually guaranteeing it is clean. It also balances your soil's acidity naturally. Sour dirt, the kind that turns your hydrangeas blue and stunts your tomatoes, gets smoothly neutralized. Anyone who hauls bags of lime every spring knows the drill. You test, spread, wait, and test again. You always have to reapply. The fix never sticks. Biochar performs that exact same job, but it lasts. The alkaline minerals trapped in its carbon frame seep out gradually, holding the acidity in a sweet, plant-loving zone for years, not just months. A single dose achieves what lime forces you to manage every single season. So, the obvious next question is the practical one. If biochar is this miraculous, how do you actually get it from a cool idea into your backyard? And what is the one massive mistake that ruins it for almost every beginner? Part 5. Bringing the jungle to your backyard. Stroll into a normal garden center and ask where the biochar is. You will usually just get a confused stare. The rare spots that do sell it usually offer tiny, colorful pouches marked up to $25 or $35. That price hike is ridiculous. If you buy it in bulk from farm suppliers or the internet, the identical stuff costs roughly $2 a pound. The fancy retail bag just makes it seem exclusive and rare. It is not. Even better, you can brew biochar at home using organic yard clippings you already have laying around. No science lab needed. The easiest method is the cone pit trick. Dig a shallow V-shaped hole. Start a blazing fire inside with dry sticks. And once you have a glowing bed of coals, start tossing in dry yard waste branches, tough stems, nut casings. Your aim is controlled charring, not burning it to ash. Choke off the air just enough so the material turns black and smokes, without bursting into open flames. When the chunks are completely blackened, lightweight, and stop smoking, drown the whole pit with water to freeze that carbon structure in place. A clean 5-gallon metal bucket with a tight lid does the trick perfectly too. Stuff it with dry plant waste, drop it right in the middle of a roaring fire pit, and let the heat bake it. The lid starves the inside of oxygen, while the fire outside brings the temperature. Once it cools down, you have pure, ready-to-use biochar. Now, listen closely to this next part before you dump a single handful of this into your garden. This is the exact hurdle where nearly everyone fails the first time. Unprocessed biochar must never be thrown straight into your dirt. Think back to those millions of hollow microscopic tunnels. Newly created biochar is incredibly dry and entirely empty. If you drop it into a planter box just like that, it behaves like a greedy sponge, sucking moisture and vital nitrogen right away from your plant roots. Your yard will actually look much worse, not better, for a few weeks. A lot of folks give this a shot, miss this crucial detail, watch their tomatoes wither, and decide the entire concept is a scam. It is not a scam. They just skip the charging phase. Charging your biochar is an ancient, incredibly easy process. Simply blend your fresh charcoal into a mound of rich compost, aged animal manure, or dunk it in a bubbling bucket of compost tea. Leave it alone for 2 to 4 weeks. While it rests, invisible life and liquid nutrients rush into those tiny caverns, moving into every single microscopic wall. The biochar transforms from a vacant subdivision into a bustling microscopic city. When this loaded material finally hits your garden, it shows up buzzing with life, immediately aiding the underground ecosystem rather than fighting it. For existing garden plots, blend roughly 2 to 4 pounds of this charged material per square foot into the top foot of dirt. For containers, patio buckets, or raised boxes, stirring in about 15 to 20% biochar by volume will yield fantastic outcomes. Your first growing season might seem a little underwhelming. That is completely normal, and you need to know why, so you do not get frustrated and quit. The underground community is still moving in. Root systems are slowly stretching into those fresh, tiny rooms. The nutrient assembly line is starting up but has not hit maximum speed yet. Many growers notice small gains the first summer, followed by absolutely explosive growth by year 2 or 3. Lush leaves, massive roots, drought resistance, and dirt that just looks beautifully rich. The progress only goes up, and it never backslides. Once it is in, it acts as permanent plumbing, not a quick spray that fades out or an additive that washes down the drain. It is a single upgrade that actually gets better as time passes, as each new season piles on more organic material, more diverse bugs, and even stronger nutrient recycling. And that staying power, the reality of creating something just one time and watching it outlive everything else, might just be the most incredible piece of this whole puzzle. Part 6. A footprint left in the dirt. The people who engineered Terra Preta are no longer here. The jungle swallowed their metropolises. Their words, their crafts, their daily routines faded into the past. Yet the earth they engineered remains, still black, still highly productive, still expanding. They did not last through stone pyramids. They lived on in a tangible, measurable sense because they permanently altered the